Welcome to Chapter 17, Nuclear Radiation. In order to understand nuclear radiation, which you may use in healthcare, if you're using a positron emission spectrum or an MRI or X-rays, many of those tools are using these types of radiation. And the first thing that you need to know is how to talk the talk. So in Chapter 17, I have the different types of particles that you may encounter in nuclear radiation. The first one is a really large one, which means that it's hard for it to get into the skin. It's one of the largest. It's an alpha particle. Sometimes, because it is an alpha particle, they'll write it like this with an alpha. And you need to know that your mass is here, overview. Your protons are here. So the mass is 4, it has 2 neutrons, 2 protons. This one right here, label this, is called a beta particle, and it's really just a high energy electron. We see these in X-rays. And you know that they try and limit it. They cover you with a lead vest so it doesn't go through lead easily. So it's much smaller than the alpha particle, but it's still pretty toxic. So they try and limit X-rays and then they try and protect you. The next one is the same, almost. It has a positive charge. It has the same mass. And if you'll remember from early on, we say that electrons are negligible mass, meaning it doesn't matter. But when you get to nuclear chemistry, it does start to matter because you have a lot of these particles. So this is a positron. Same thing as the high-speed electron beta particle. The only difference is the charge. So the mass isn't really important like it is with the alpha particle. Right here, we have the proton. They typically draw a proton. And then the last one that I've written up here is a neutron. Notice that the neutron has a 0 here because you don't have a proton in there. You just have a 1 charge, 1 AMU charge, because it is a neutron. For the proton, the ones and the ones are identical. The mass is 1. There's 1 proton, so they just write it twice. The only one I didn't put up here is probably the most dangerous. Those are gamma rays. Gamma particles. These are the most dangerous because they have the most power. They're the smallest, but they can go through up to 10 feet of concrete. So gamma particles are what we really worry about in nuclear fallout. We worry about all, but particularly the gamma.